5 years ago, I started a water filtration business because we found out that over half of the population in Kenya do not have access to clean water. Our filtration system do not work because there is a very big linkage between water shortage and water contamination. And this situation is global. 7 million people are experiencing water shortage right now.
The last 3 months, residents of Nairobi have been digging deeper into their pockets to buy water as drought persists. In Kayole Estate, residents say they've not had water for the last 2 months and are therefore used to dry taps. And as others marked World Water Day, there was little to celebrate as residents here are feeling the pinch of the water rationing program that started in January. Water supply to the estate has been erratic. The water rationing program, they say, had worsened the crisis, with many households not getting up water for up to 4 months.
This is a huge problem around the world. So we thought about, well, how do we get people in this situation with water where they are? There's actually 6 times as much water in the air as there is in all of the rivers in the world. It's just, traditionally, you don't really have a way of capturing that water. So we thought about different materials and substances that could help, and thought about desiccant materials. So these are sponge-like materials which have a great affinity to water. We decided to test these materials first of all in the lab. So we got just some silica, exposed it to the atmosphere, then heated it up in a closed system with a distillator, and we got water out at the other end. So that started to get us really excited about, okay, how can we now prove that this works at scale using minimal energy?
We used existing pieces of hardware and we linked them together to see how they would work. We connected a solar panel system to a desiccant dehumidifier, and the water output we connected to a handmade activated charcoal filter. And what we wanted to do was prove that these pieces could come together feasibly in a system that would be appropriate for our target region.
The machine has been running for about 10 minutes here, and you can see the quantity of water that's already formed directly out of the air.
Great, fast forward 7 months and we're here in Kayole, which is a slum on the outskirts of Nairobi, where we're working with a local engineering firm who do a lot of water technology to build our next prototype. We have these beds of silica gel. A fan draws air through, and then the silica absorbs the water from that air. Once it's been recharging for a few hours, we will extract these beds, put them into the oven up top, which will be heated by the solar thermal concentrator. Then the water will be released from the silica gel and collected as water vapor for drinking. So you can see that device is actually quite big. It produces 5 litres of water. That's because we wanted to make something here in Kenya and test the solar concentrator. Long term, our design will be much smaller. It will use a desiccant wheel to maximise surface area, and we'll also be producing offshore, likely in China.
Majik, we want to see a world where a woman doesn't have to walk for 4 hours just to get 20 litres of water. As long as you have air, you'll have fresh drinking water.